This is my video solution to the immediately past 2021 Northern Hemisphere timetable Math Method Exam 2. Before I start doing the video solution, I would like to disclaim that this suggested solution is not intended to be exemplary, and it is in no way endorsed by VCEE. VCEE retains all rights related to the exam material, and this is just my personal suggestions to the past exam for nonprofit pedagogical usages only. So let's get started. Firstly, I quickly summarized my suggested solution to the 20 multiple choice questions. Let's look at the first one. The graph below shows one cycle of a circular function. Basically, you just need to identify the center line of this sine graph or cosine graph, and also the period is 1. By the way, the amplitude is the distance from the maximum to the center line here. So I would say option E best fits the requirement of the graph. And you could also confirm that by sketching that function on your CAS calculator. Question 2. If 3f of x equals f of 3x for all x greater than 0, then the rule for f could be. So I try the first one, and then I type 3f of x equals f of 3x in my CAS calculator, which comes with the result true. That means option A is the correct option. Question 3. The function of f of x is x to the power of 4 divided by 4 minus x cubed divided by 3 minus 9x squared over 2 plus 9x. We'll have an inverse function for a certain domain. So the D here is my restricted domain. To become an inverse function, I would like this function to be 1-to-1. If you sketch the graph on your CAS calculator over a suitable viewing window, you will find the first turning point, which is a local minimum, is at x equals minus 3. In the middle, you have a local maximum at x equals 1. From -3 to 1, the graph is strictly increasing. So if I just restrict my graph of f from here to here, the graph will be 1-to-1. That means option B will be a suitable answer to this function, which becomes a 1-to-1 function. Question 4. We have a cubic polynomial with unknowns a, b, and c. It must have a turning point at x equals 3 and a y-intercept at y equals 9. The approach I adapted was to putting the values of a, b, c from the options and sketch the corresponding graph on CAS calculator. If I used option A with a equals -5, b equals 3, and c equals 9, here is what I've got on my CAS calculator. We notice there is a y-intercept at 0,9 and a turning point or repeated root at x equals 3, y equals 0. That satisfies my condition for the prescribed cubic function. So option A will be the correct response. Question 5 is a typically year 11 logarithmic question. So what I'm doing here is I'm using the log laws by separating the division sign here using subtraction, and then I keep separating the second term, which gives us half log 3 5 minus 2 log 3 q minus log 3p. So this is pretty straightforward. Option C is our correct response. Question 6 wants us to find the sum of the first 4 positive solutions to the equation tangent 2x minus 1 equals 0. Here, I used the command on my CAS calculator, zeros, to find the x-intercepts for this function. Notice that I used the domain 0 to 2 pi. That is, I noticed One period for tangent 2x will be half pi. So if I want to have 4 positive solutions, within one period, I would have one solution. Within 4 periods, I would get 4 solutions. That's why I used 0 to 2 pi as my restricted domain. With the output here, I just transcribed it into another line of command, sum. So I sum up all 4 solutions, then I will get 7 pi on 2, which means D is the correct response. Part of the graph of y equals f dash is shown in the diagram below. Here we can see this graph looks like a up-front parabola. We notice that f of 0 is 1, which means the original function or the antiderivative of that graph will pass through 0, 1. If I compare all options, we will notice only option B and option C will pass through 0, 1. And also, this graph, the derivative function is a positive quadratic, which means the antiderivative must also be positive cubic. So option B will be appropriate. Option D and E represents the possible derivative functions. But if we want to find the derivative function of that f dash of x, we will definitely have option D because it's an up-rising linear function. Okay? Question 8. Part of the graph of a polynomial function f is shown below. This graph has a turning point at minus root 2 times 2 minus 1 and 2 root 2 minus 1. So we want to get f of x to become strictly decreasing, which means I could choose this bit from negative infinity to the left turning point x value, and from 0 to x equals 2 root 2. For strictly decreasing, I need to include the endpoints. These endpoints is also a turning point. That's why we can have negative infinity minus 2 root 2 inclusive 0 to root 2 inclusive. Question 9. The continuous and differentiable function f defined on all real numbers has roots at x equals 1 and x equals 6 and a repeated root at x equals 4. Given that 1 to 4 f of x dx is a and 4 to 6 antiderivative of f equals b, a, b are real numbers. We want to find the value of 1 to 6 f of x plus 1 dx. In this case, I just quickly draw a possible graph. Notice that x equals 4 is a repeated root. Therefore, my graph could have this bit all above or just on the x-axis. Plus 1 means lifting the whole graph by 1 unit up. So this is a rectangle with area 5, which can be calculated from 1 to 6 integral 1 dx. The first bit, 1 to 6 f of x dx, is the sum of these two integrals given in the question. So it's a plus b. Therefore, I will choose option C. Question 10. We have a quadratic graph minus x squared minus 4x plus 5. And we want to find the tangent to the graph when it's parallel to the line connecting the negative x-intercept and the y-intercept of f. So what is the x value? If you quickly draw the graph of that, then you will notice the only negative x-intercept is minus 5, 0, and the y-intercept is 0, 5. To get the gradient, you can calculate from y2 minus y1 over x2 minus x1. So the gradient is 1. And then if the tangent is parallel to the line here, then their gradients must be equal to each other. So the derivative of f is minus 2x minus 4, which is 1. Solving that equation for x, you will get minus 5 over 2. Choose B. Question 11 is about calculating the sample proportion, and it's confidence interval. The approximate 95% confidence interval for the proportion of people who own the yellow rubber duck was 0.6299.699. And we want to find the unknown value for n, which is the number of trial or number of people in the random sample. Basically, you just need to recall the margin of error, which is half of the width of the confidence interval. For 95% confidence interval, you can't use z equals 2 or minus 2. You have to use 1.96, or more accurately, you should use 1.95996 something, multiplied by the standard error or the standard deviation of p hat. Now, to get the value of p hat, I just add up the two boundaries and divide it by 2. So I would get 0.6499 or 6,499 over 10,000. Then I subtract this number from the C upper value. And I will equate that distance to the margin of error here. This p hat represents the number here, and I solve for n, which means I will get n equals 2,184.975. Correct to the nearest integer because we have to use whole number to represent the number of trials. So it's 2,185. Question 12. If you could spot the answer by inspection, that will be the most efficient way to tackle this question. You just notice you can do the dilation by a factor of 2 from the x-axis, which means you're multiplying this bit by 2. And then you're translating the graph to the right by 1 unit, which is indicated by x minus 1 bracket cubed. And finally, you notice the +4, the constant for the image function, which means it's translated upwards by 4 units. So the corresponding matrix equation should be option A. You can also use your CAS calculator to verify your observations. Question 13 is pretty straightforward. You just define P of x. But remember, between K and X, on your CAS calculator, you have to put the multiplication sign. Otherwise, it will recognize Kx as a whole variable. Then you just use solve with the given condition here. For which variable? For A, because we want to find the value of A. So the output returns natural log 2 over K, which means B is your correct option. Question 14 gives you a probability density function for a continuous random variable x. Its effective domain is greater than or equal to 0, which means 0 to infinity. So to get the variance of x, you have to calculate the mu first, the mean value. That is done by multiplying the function by x, then anti-deriving it from 0 to infinity. And this could be done on your CAS calculator, which gives you 5. And then you calculate 0 to infinity, the antiderivative, x minus mu squared, which is x minus 5 squared, multiplied by the function itself. Make sure you multiply them within the integral rather than outside the integral. Using your CAS calculator, you could obtain the variance of x, 25. Question 15. The graphs of functions f and g are shown below. Both functions have the same domain of 0 to b, where b is a positive number, and the same average value. Basically, the left-hand side graph is a triangle, so the area is half times b times 2b, which is b squared. The average value is the signed area divided by the interval length, which is b. The right-hand side, you have a rectangle, so the area is simply 8b, and the average value is 8, because 8b divided by b, the interval length is 8. Equating these two expressions, you will directly get option D. The value of b is equal to 8. Question 16. In a particular city, it is known that 70% of all adults get their hair cut every month. A random sample of 720 adults from this city is selected. So 0.7 is your population proportion, and 720 is your number of trials. We want the proportion of adults who get their hair cut every month is greater than 0.72. So your p hat is greater than 0.72, and your x value, your desired number of people getting their hair cut every month, is 518.4. But to use the binomial CDF, you must realize this is a discrete random variable. You can't have 0.4 something. So according to the inequality greater than that value, the nearest next integer value will be 519. That's why I use my binomial CDF from 519 to 720. So the answer is 0.1187 approximately, and the answer is C. Question 17. Part of the graph of the function is f is shown below. The smallest positive x-intercept of the graph occurs at x equals a. The horizontal line is a tangent to f at the local minimum b f of b. Notice that this fb is a negative value, which helps us to define the correct expression for the shaded area later. So to express the shaded area, because f of b is less than 0, it's below the x-axis. b times fb, which gives you the area of the rectangle here. It is a negative area. To compensate the negative, you have to put another negative in front of it. And then from A to B, this bit is a negative area. So A to B anti-deriving f of x dx is less than 0. To calculate the magnitude of this shaded area, you just simply add these two expressions up. And it could be written as A to B f of x dx minus b fb. Observing all options, option E is the only correct response. Question 18. Given that the derivative of x cosine x is cos x minus x sine x, we want to find the antiderivative of x sine x. So you just need to integrate each term in that equation, and you will get cosine x antiderivative minus x sine x antiderivative. That equals to x cos x, because if you antiderive this term, it will cancel d dx. And rearrange it, you will get option D as your correct response. Question 19 is actually very conceptual and in some ways very challenging. So a cubic polynomial f has roots at x equals 1 and x equals 3. These are the only two x-intercepts, and its graph must have an y-intercept at y equals 3. In that case, I would say you could either draw a graph like this or a graph like this. But if it has a y-intercept at y equals 3, looks like it can only touch x equals 1. If you want to find the correct statement about g of x equals root f of x, you should notice that to make sure root f of x is defined, the inner part must be greater than or equal to 0. So you start to observe your rough sketch of f of x. From the graph, you can see from negative infinity to 1. Yes, that's good. It's above or at the x-axis. From 1 to 3, including 3, okay, that's still positive or 0. I mean the y value. But after x equals 3, that's another story. The graph of f becomes below the x-axis. So we must get rid of any parts below the x-axis. That is from 3 to infinity, greater than 3. That's why we choose option E. Question 20, in some ways, is challenging, but if you notice the basic properties of probability distribution, whether it be discrete or continuous, you will tackle it very easily. Firstly, you should notice that the sum of all probabilities in this table must be equal to 1. That is one key to this question. If you solve that equation, this bit plus this bit plus the third probability and the fourth probability equals 1. Solving for B on your CAS, you get 3 possible values. Another counterintuitive understanding to this question is B is not necessarily greater than 0 unless it's a probability itself. Why am I saying that? Because you noticed in these 3 cells, none of these cells are simply B or a simple multiple of B. That is, my B value could actually be negative. As long as my B value makes each cell positive or 0, I will still satisfy the condition because all probabilities must be lying within 0 to 1. So I use solve 3 times. I solved this one greater than or equal to 0, this one greater than or equal to 0, and this one greater than or equal to 0. Finally, we find a very long condition, the constraints for B. Out of the 3 values here, only minus 0.4 will satisfy these inequalities. That's why the value of B is option A, okay? So that completes my solutions to the 20 multiple choice questions. Let's move on to the next part, the 60 marks extended response questions. Every time you're tackling the extended response questions, never forget to reread the instructions for section B. You must answer all questions in the space provided, especially when you are tackling the November exams in Southern Hemisphere, because your exams will be scanned and are uploaded to a certain system of VCEE. And all assessors will only mark your scripts on the screen instead of the hard copies. In all questions where a numerical answer is required, an exact value must be given unless otherwise specified. So if you never see a phrase like correct to, always leave your answer as fractions or thirds or exponentials or possibly logarithmics, okay? In questions where more than 1 mark is available, appropriate working must be shown. This is actually in favor of all exam candidates. So if you get a correct answer but showing no working, you could either get full marks or 0. But if you made any mistakes when you are using some sort of approaches without showing any working, you get definitely 0 mark. Unless otherwise indicated, the diagrams in this book are not drawn to scale. We hold on to that. Sometimes it's not always true, but it is the safest approach to start from the first principle and derive your answers using appropriate working. So let's look at the first question. You can see I took a screenshot here. That's because I want to emphasize the importance of defining the function or sketching the graph first, especially when you are tackling math method exam 2s. At the beginning, question 1 gives you 2 functions, f and g. You can see in my previous slide, I defined them by sketching them. which are f1 of x and g and f2 of x. For g of x, the period is 2 pi, and the amplitude is the coefficient in the front. Sometimes it could be -2, then your amplitude must be +2. Always remember your amplitude must be a positive value. The second part, you want to find the value of c for which fc equals 0. C goes from 0 to half pi. So on my CAS calculator, I just solved f1c equals 0, comma c. Notice the little letter I use here, c instead of an x. When you are answering this part of the question, you never say x equals pi on 6, even though we know it's an x value. You have to stick to the requirement, the value of letter c, okay? And then we find the minimum value of f. This is done by using fmin command on your CAS calculator. Here, I just chose an appropriate domain, for example, -pi to pi. And from previous slide, you can observe this is the lowest point with y value -2, okay? Notice that I did not need to state the values of x because the question hasn't asked me to state the value of x. So you just simply say f minimum equals -2. Parts of the graphs of a function of f and g are shown below. The graphs of f and g touch but do not cross. That is an important phrase to look at points pq and pi on 3v. So by inspection, you should immediately notice these 2 points are symmetrical about the y-axis, which means your p-value is -pi/3. And then to get the value of q, you just simply substitute the x value pi/3 into either f or g, okay? Or you could substitute the p-value into either f or g. So q equals 1. And then you want to find the value of the derivative of f and the value of the derivative of g at x equals pi on 3. Make sure you state the derivatives separately, okay? Even though they indicate the same value. So f dash of pi on 3 equals -√3. G dash pi on 3 is also equal to -√3. And then you find the equation of tangent to the graph of f and g at x equals pi on 3. This is done by using tangent line command on your CAS calculator. With reference to f1 of x, I've defined at the first page, okay? Make sure you write y equals because we want the equation rather than an expression. So that's the next part. This is also done using normal line command on CAS calculator. And here is your answer for the equation of the line perpendicular to the graph of f and g at the same x value pi/3. All right. The area bounded by the graphs of f and g is shaded in the diagram below. Find the area of the shaded region. Notice that at x equals -pi/3 or pi/3, they just touch each other instead of crossing each other. So you can directly go from -pi/2 to pi/2 and anti-derive g minus f. On my CAS calculator, the corresponding expression should be f2 of x minus f1 of x, okay? But on your paper, you have to be consistent with the notations given in the question. G of x minus f of x. And the area is 4. So question 1 is pretty easy and straightforward. Let's move on to the next one. Question 2, the function h is a product of a truncus and a logarithmic function. The domain is 10 to 50. Notice the little phrase here. Normally, if we see the phrase the rate it means the derivative of something, but h here is the rate itself. So in this question, our y value means the rate at which the heat is lost from water. The hot water pipe with or without insulation is illustrated in this diagram. The inner circle, the inner white circle, is the cross-section area of the pipe. The outer shell is the insulation part with X value here measured from 0. So the hot water pipe without insulation is 10 millimeters. That's why our domain goes from 10 to 50. So the maximum insulation length should be 50 millimeters. And the question gives us a nicely drawn diagram, very much to the scale. And we want to find the rate at which the heat is lost from the water in the pipe with no insulation. Here, no doesn't mean x equals 0. It's actually x equals 10, the left end point on this graph. So you substitute x equals 10 and you get 28.562, correct to 3 decimal places. State the derivative of h of x. This is done on my CAS calculator, and you could define h at the beginning with its domain. And the maximum rate at which heat is lost from the water, correct to 3 decimal places. If you look at the previous diagram, the maximum rate h occurs at this turning point here. And you could find that on your graphical analysis part on your CAS calculator. Alternatively, you could use fmax command and using the domain 10 to 50. The x value is 11.59488, etc. The y value, which is obtained by the substitution as indicated here. A particular insulated pipe has the same rate of heat loss from the water as a pipe with no insulation. So we simply equate h of 10 to h of x and solve for another possible value of x, which must be greater than 10, okay? Part D. If both the radius of the pipe without insulation and the radius of the pipe with insulation, as shown in the diagram on page 14, are doubled, here, the length of the insulation is doubled. We want to find a new function for the rate of heat lost from the water. And notice that they used h1 instead of h. That means h1 is a different function, but it's obtained by certain transformation onto the graph of h. We also want to state the domain of h1. If the radius of the pipe with or without insulation is doubled, then you can substitute x over 2 into h, which means your new function will be given by 3,200 divided by x over 2 minus 10 instead of x minus 10. And then the next part, you just need to do some algebraic manipulation. Notice that you can combine these two terms and take the common denominator. When you square it, you could get 4 below x minus 10 squared. Flip that around, you will get 12,800 as your first part numerator. And the next part, inside the argument of the log, you will get x minus 10 over 8. Actually, I've got a typo here. This should be 5 instead of 10. I'll fix that later. Just for your reference, change this one to 5, okay, when you are completing this question. Don't forget to state the domain of h1. h has domain 10 to 50. If you are dilating the function by a factor of 2 from the y-axis. Only the x values will be affected. So your new domain will be doubling the endpoints, which is 20 to 100. And you want to describe the transformation that maps the graph of H to the graph of H1. That is dilation by a factor of 2 from the y-axis. And you can see here, with my cast command, I simply obtain the answer, but it is highly recommended you show the substitution process and some basic algebra. With the appropriate manipulations, you obtain the answer as shown, okay? Find the area between the graph of H1 and the horizontal axis over its domain, which is 20 to 100. Give your answer correct to 3 decimal places. So you anti-deriving H1 of x from 20 to 100. This will be 1079.171. Correct to 3 decimal places. In this part, this is denoted by capital letter A, the area found in part E1. We want to determine the area between the graph of H and the horizontal axis over its domain, which is 10 to 50. I believe it's simply half of this area, okay? Because from H to H1, you are doubling the horizontal length. So you're doubling the area of the first function to a transformed function. Question 3. The parabolic arc of a tunnel is modeled by the function f from negative c to c. F of x is ax squared plus b, where a is less than 0, b is any real number, and c is greater than 0. Let x be the horizontal distance in meters from the origin, and let y be the vertical distance in meters above the base of the arc. The graph of f is shown below, where the coordinates of the y-intercept are 0, k, and the coordinates of the x-intercepts are minus c0 and c0. We want to express a and b's in terms of c and k. So k value here is simply the local maximum on the parabola. B is equal to k. And if you substitute f of c equals 0 with your given rule of the parabola and solve simultaneously, you could directly get a equals minus k over c squared. And notice the minus here, a is less than 0. So you have to have a minus in the front, okay? A particular tunnel has an arc modeled by f. It has a height of 6 meters at the center, so my k value is 6, and a width with 8 meters at its base. If you notice the graph here, 8 meters is from here to here, so half of its length is the c value, so c is 4. Once you substitute k value and the correct c value into a and b, you will get the expression here. So the rule for this arc is minus 3 over 8x squared plus 6. The domain is negative 4 to 4, but the question didn't ask us to find the domain. So you could omit that when you are completing the same question. A track that has a height of 3.7 meters and a width of 2.7 meters will feed through the arc with the function f found in part bi. Assuming that a truck drives directly through the middle of the arc, so this length must be equal to that length. Let d be the minimum distance between the arc and the top corner of the truck. We want to find the minimum distance d and the value of x for which this occurs. Correct to 3 decimal places. So the width is 2.7, and the x value from here to here should be 1.35. The height from the ground is 3.7. With the coordinate here 1.35 and 3.7, I use the Pythagorean theorem or distance formula. On the graph of f, the coordinate is x, f of x. So I can calculate the distance as indicated in my CAS entries. Then I just do f min dx comma x, comma 0 to 4, because 0 to 4 is an appropriate domain. I know the point should lie within this domain along the curve. And I get 2.1850649, etc. Alternatively, you could solve derivative of that equals to 0 for x. Notice x is greater than 0, and you should get 2.18506, etc. Finally, don't forget to substitute this x value into d of x for the minimum length itself, because d represents the length from this point to the parabola, okay? And the minimum length is 0.978255, etc. Correct to 3 decimal places. I ran the answers as 2.185, 0.978. A different tunnel has a semicircular arc. This arc can be modeled by the function from -6 to 6, g of x equals root r squared minus x squared. Notice that r is the radius. R squared is the radius squared. The value of r is simply 6. Two lights have been placed on the arc to light the entrance of the tunnel. The positions of the lights are minus root 11.5 and root 11.5. The area that is lit by these lights is shaded in the diagram below. We want to determine the proportion of the cross-sectional area of the tunnel entrance that is lit by the lights, and give your answer as a percentage, correct to the nearest integer. So it's something percent. How could we tackle this question? Well, firstly, I used equating the gradients to find the possible y-intercept, which is here. This is done by finding the gradient between this point and this point, and also the gradient between this point, the y-intercept, and the 6, 0. Why am I doing that? Because if I have the y-intercept here, I could easily work out the area of this triangle from -6 to 6 and this value here. With this area, I noticed that if I simply find the area of this big triangle and subtract this smaller triangle from the big triangle, I would get half of the shaded area, which is indicated here. And notice that I multiply the whole thing by 2, which is the total shaded area. For the best accuracy, I keep my answer as a third, okay? Finally, we want to find a proportion of the cross-sectional area of the tunnel. We know this is a semicircle. So I just divide this number by the area of a semicircle, which is half pi times 6 squared. And then I multiply the ratio by 100 to get a percentage answer. The percentage answer is 71.9375, etc. percent. Rounded to the nearest integer, it should be 72%, okay? In this question, we have two important special shapes. One is to do with circle, a semicircle. Another part is to do with triangles. So using anti-differentiation here for the area between curves will not be recommended. Question 4 is merely about probability and statistics. Let's have a look. A particular petrol station has 2 air pumps, A and B, to inflate tires. Each inflation of a tire is independent of any other inflation of a tire. When a pump A is set to 320 kilopascals, the pressure that the tires will be inflated to follows a normal distribution with a mean of 320 kilopascals and a standard deviation of 10 kilopascals. Find the probability that a tire will be inflated to a pressure greater than 330 kilopascals when inflated by pump A, correct to 4 decimal places. This can be done using normal CDF command from 330 to infinity using the mean 320 and the standard deviation 10. Notice that I used XA to denote the normal distribution, but when you are writing the notation, make sure you write the variance here, which is 10 squared. So the probability of XA greater than 330 is 0.1587, correct to 4 decimal places. The probability that a tire is inflated by a pump A to a pressure greater than A is 0.9. Find the value of A correct to the nearest kilopascal. So you should notice that it's greater than A. Probability XA is greater than A is 0.9. So the opposite, XA less than A, has its probability 0.1. Okay, the opposite. The reason why I'm using the opposite is because TI-Nspire can only recognize the left tail probability when you are using inverse norm CDF. That's why you have to put 0.1 here instead of 0.9. So every time you're using inverse norm CDF, make sure you recognize the correct tail. Is the tail left? Alternatively, you could work out the z value corresponding to the area 0.1 under a standard normal distribution, which is roughly minus 1.28155. And you could use x minus mu over sigma to solve for A. Therefore, correcting the nearest kilopascal, A is about 307. Now with pump B, we have a new probability density function, which is a cubic function over the domain 310 to 330. We want to determine the mean tire pressure for tires inflated by pump B. So we multiply B of x by x and integrate it from 310 to 330, which is its effective domain. And you should get the mean value is 322 kilopascals. A randomly selected tire is inflated by pump B. Find the probability that this tire will be inflated to a pressure greater than the mean tire pressure of tires inflated by pump B, correct to 4 decimal places. So I know the x value here represents the pressure for pump B. It can be no more than 330. It must be greater than 322. So we are anti-deriving this probability density function from this value to 330. Even though this is an exact value, we still want to write it as decimal form, correct to 4 decimal places. If you press Ctrl Enter on your CAS calculator, you will get a nice number 0.5248, exactly 4 decimal places. This is an exact decimal answer. Then you want to find the value of K such that the probability that a tire is inflated by pump B to a pressure less than K is 0.95. So you are anti-deriving B of x from 310 to K, and the probability or the area is 0.95. Notice that I used the solve command on my CAS calculator for K, and the K value is approximately 328 kilopascals. Part F is a typical two-stage experiment question or conditional probability question. It says a motorist is equally likely to use either pump A or pump B to inflate one of their car's tires. And we want to find the probability that a motorist has used pump A given that the tire is inflated to a pressure greater than 325 kilopascal. Give your answer correct to 4 decimal places. Of course, you need to recognize the correct conditional statement. It's probability A, pump A, given any pump could have pressure greater than 325. So the top part is actually an intersection divided by probability pressure greater than 325. I'll fix the typo later. Now you should have an intersection sign here, okay? An inverted U. And then you could find the probability of pump A greater than 325 by using Binomcdf. Notice that I assigned this probability to a letter PA. And also the probability of pump B greater than 325 is calculated using the integral from 325 to 330 of Bx, okay? And finally, we know it is equally likely to use either pump A. If you draw a tree diagram, it will be easily illustrated. So it's the probability of choosing pump A times the probability pump A greater than 325 divided by the total probability. It's either pump A greater than 325 or pump B greater than 325. So you sum them up. And the final answer should be 0.5410506, etc. Corrected 4 decimal places is 0.5411. Okay, now let me get rid of the annotation. The company that manufactures the pump test all of its pumps and remove those are defective. The probability that a randomly selected pump is defective from all of the pumps tested is 0.08. So the probability of getting one defective pump is 0.08. That is my probability of success. We want to find the probability that 4 pumps are defective. So x equals 4. From a sample of 25, n is 25. Correct to 4 decimal places. Let's say D is a binomial distribution, n equals 25, p equals 0.08. So when D equals 4, the probability is 25 choose 4 times 0.08 to the power of 4 times 0.92 to the power of 21. Of course, once you identified its binomial distribution, it's not necessary to write this one here. But I just want to make sure my answer is comprehensive. Calculating from Binomcdf or Binomcdf here, I just put the same lower bound and upper bound, which is effectively the same thing for Binomcdf. The answer is 0.0899. For random samples of 25 pumps, p hat is a random variable that represents the proportion of pumps that are defective. Find the probability that p hat is greater than 15%, correct to 4 decimal places. So p hat is d over n is 25. When p hat is greater than 15%, which is greater than 0.15, you can multiply this inequality by n. So the d here will be the number of defective items or defective pumps. It must be greater than 3.75. But we know the d value, or whichever letter you use, let's say x, must be whole number because binomial distribution is a discrete random variable. It cannot take any decimal values, not like continuous random variables. So the least value of d you could take here is 4. And the uppermost value is 25, the maximum value of d, which is the number of trial. Using Binomcdf again, you could get the answer is 0.1351, okay? Lastly, for random samples of n pumps, p hat n is the random variable that represents the proportion of pumps that are defective. Find the least value of n such that probability p hat n less than 1 over n is less than 0.15. So here I adapted an approach not very familiar to many students. is called inverse binomial n, looking for the unknown sample size n. Of course, you could also multiply this inequality by n both sides. You could get xn less than 1, which means the x value can only take 0. So all items must be non-defective, which means 0.92 to the power of n must be less than 0.15. Solving that inequality, you could get n greater than 22.75. So the smallest value of n is 23. Alternatively, you could use trial and error. You test when n equals 22. The probability of x equals 0 is 0.1597, which is greater than 0.15. But when you take n equals 23, the probability is immediately less than 0.15. With these two calculations, you can then conclude the smallest value of n is 23, okay, by showing sufficient amount of trials and errors. Lastly, question 5 is a typically differentiating question to differentiate the top students. Normally, this question asks students about aspects of varying parameter. So it starts off with two specific functions with known constant in it. F is a right-hand side truncus, x greater than 0. G is a linear function going downwards. At the beginning, I defined f and g separately in one problem on my CAS calculator. To find the coordinates of the points of intersection between f and g, labeled A and B in the diagram above, notice that A has a smaller x value, B has a larger x value. Once you obtain their coordinates, you have to identify clearly which coordinate means A, which coordinate is for B, okay? This is done by solving simultaneous equations, y equals f of x and y equals g of x, or you could use a shortcut called zeros. Notice that I put the constraint x greater than 0 because both points are on the right-hand side of the y-axis. And the way to interpret the output is x equals that, y equals that. Another x equals half, y equals minus 2 on 5, okay? In coordinate form, that's your final answers. And then you want to determine the area bounded by the graph of f and g between A and B. Give your answer in the form r plus s root t over u. These four letters are all integers. So you are anti-deriving g minus f from half to root 3 plus 1 over 2. But the output from your CAS calculator is not satisfying the requirement yet. So you have to combine these two terms as one single fraction. And then your final answer should be written as minus 9 plus 6 root 3 over 10 to address the requirement of the form given in the question, okay? This is addressing all possible details when you are answering exam 2 for math method. And then from this point on, we are swapping the numbers with letters. So now it's the parameter part of the question. We want to find the value of A for which P equals F and Q equals G. So basically, you just keep defining P and Q separately. Make sure between A and X, you put a multiplication sign, okay? And the bracket here, between bracket 1 minus A and X, you put another multiplication sign to avoid any errors. And then you just equate F to P, you get A equals 5. It's the same as doing Q equals G, which will also give you A equals 5. Find the positive x-intercept of P in terms of A. So you're equating P of x to 0. And notice x must be greater than 0 because R plus is your implied domain. and a is greater than 1. This is the domain for the parameter. So x equals 1 on root a plus 1 only, and a must be greater than 1 to follow through. Of course, you can also put that in coordinate form, 1 over root a plus 1, comma 0. Point M lies on the graph of y equals p of x. The tangent to p at M is parallel to q. Find the x-coordinate of M in terms of a. So the derivative of p with respect to x is equal to the gradient of this straight line here. And x must be greater than 0. If you solve that on your CAS calculator for x, you will get this nice expression 2 to the power of 1 over 3 divided by a minus 1 to the power of 1 over 3. So this is the x-coordinate of M in terms of a, but you don't need to find the y-coordinate because the expression is too ugly. So you just need to state this value here. Then you want to find the y-intercept of a tangent to P at M in terms of a. Notice that you just find this x value here. So you want to find a tangent line to this one at this x value. On my CAS calculator, I press menu 49 to get a tangent line command. And here is the full equation for the tangent line. But we only want the y-intercept. So once you put down the y equals blah, 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 then don't forget to write down the y-intercept itself, okay? And that is the intended answer by the question, as far as I understood. The next part is incorporated with part 1. Given that 2x over 3 greater than or equal to 2 to the power of third times x minus 1 to the power of 2/3 for all x greater than 1, show that the tangent to P parallel to Q will have a negative y-intercept for all a greater than 1. So this bit is a given useful condition for you to use, and you want to prove that this expression is less than 0. So how could we do that? Firstly, we swap x by a, which is also true because here a is also greater than 1. That means with a here and here, this inequality is true. And then you try to manipulate this bit to match the y-intercept expression. This can be done by multiplying both sides by 3. So we are getting very close to the expression. Look at the top part. You have 3a minus 1, 2 over 3, 2 to the power of 1 over 3. And then, if you want to prove that is less than 0, why don't you move 2a to another side? So you are effectively subtracting 2a from both sides of this equation. You will get this bit, take away 2a less than or equal to 0. And compare this bit with the top part here. You're still missing the 2 times 1, which is minus 2. So you keep subtracting both sides by 2. And you can then tidy 2a minus 2 up, which becomes minus 2a plus 1 in a bracket. So now you can divide both sides by 2a. Because a is greater than 1, 2a must be greater than 2. You're dividing both sides by a positive number. It's not changing the direction of the inequality. Finally, once you know this bit must be greater than or equal to minus 2 over 2a, you realize, okie dokie, this number here is a negative value, which must be less than 0. So your y-intercept found in previous part must be less than 0, okay? Very tedious, but if you try to match and pair and manipulate the given expression bit by bit, it won't be very far from getting this 1 mark. Part 3. The tangent to P parallel to Q has a negative y-intercept. Explain why this implies P and Q will always enclose a region bounded by both graphs for all a greater than 1. Here, you can see I did a rough sketch on my PowerPoint, which I also did when I'm completing the actual physical paper. You know, this orange line represents the Q of X, right? And this curve is P of X. From previous part, we know M is the tangential point on the graph of P. This tangent line has a negative y-intercept. As long as this tangent line has a negative y-intercept, it must lie below this orange line, which is Q. On the other hand, you could also argue this orange line is always above this tangent line because it must pass through 0, 0, the origin. So once the straight line is always above the tangent line, this guarantees 2 points of intersection between the orange line and the blue line, which means this is a secant, and this region bounded by the curve and the straight line must be greater than 0. So to explain why this implies P and Q will always enclose a region bounded by both graphs, you have to mention the relative position of the y-intercepts. Of course, you could also comment on their parallel gradients, okay? Another thing I should mention, okay, I mentioned here, the parallel tangent. Yep, I mentioned the gradients are the same. Finally, parts of the graphs of P and Q are shown below for when A equals 100. The shaded area is bounded by the graphs of P and Q. Find the smallest value B such that the shaded area is less than B for all A greater than or equal to 100. Well, if you take a look at 2016 Math Method Exam 2 and the 2017 Math Method Exam 2, the last part, the very last part, it's the typical question again, finding the limit for the bounded area. Normally, it's something to do with the rectangle or sometimes square. In this case, it's bounded within this little triangle here. Of course, proving that holds true is beyond our course at this moment. So we have to use sliders to observe the pattern. Here, I just sketched 2 graphs involving the parameter A. So I created a slider for A. And also the slider goes from 100 to 10,000, which I think should be sufficient to observe its pattern. Once I put the A very large, for example, to 6,000, 8,000, and 9,000 up to 10,000, you will see this shape will converge to a triangle. The triangle should have an area of half times 1 times 1, which is half. So the smallest value of B I could think of using the graphical interpretation is just half. So that is the end of Math Method Exam 1 2021 Northern Hemisphere timetable. I hope you could find this video helpful in some way, and hopefully later I could upload more videos regarding the past exam solutions for other subjects. Thanks for watching, and I'll see you all next time. Bye-bye.